Alright, so in this section, I'd like to cover the important properties of the opacity graph, the shading, and the look and feel of the fluids. Okay, so till now we have completed the sections of the dynamic simulations, fluid emitters, and the density and the velocity sections. Now we'd like to jump over the most important section of the look and feel, because the look and feel is the most important aspect of the fluid, which is going to make you decide what exactly is happening inside the 3D softwares. Okay, so just by the look and feel, we may get able to realize that yes, exactly, this is the motion which is we're going to talk about. So moving again back uh, to the shading section, you can see, let me just first of all work upon the transparency. So for the dry ice, it's really not going to be too much transparent and not too much dense. So what I can do is that I can play around with the value of maybe 0.55 to maybe 0.5. Okay, that's fine. You wish to change the color of the dry ice in your composing packages also, but let's say just here for a very quick demonstrations, I like to go for a little bit gray kind of a color, or just dip down the value of the color so that we just don't have completely white dry ice. Although in maximum of the cases, or the default hue, or not exactly the hue, the default color of the dry ice, it seems to be white. Okay, the incandescence is not really going to play any role, so just I could just switch that off. Now the most important sections in the look and feel, which is the opacity. Now this graph is really going to be I must have to say tricky, so we have to deal that thing with very carefully. You know what, when I was working with the dry ice, I tried to make 2 to 3 adjustments of the graph, and I came to know that one of the best graph was that you need to have a little bit you know less fluids near around the corners of the dry ice. Now we're going to show you up with the play blast, and later you're going to realize that what exactly is the advantage using this particular graph. Okay, so I can start making, we can start sculpting the graph quickly. With the interpolation, set that thing to the spline, and again set that thing to the spline. I just want to have a point over here, and just to make that thing a little bit down again, and I guess we are done with the graph. So it was pretty much fast and easy to build up the graph. Okay, you know what, I just want to have some I would like to share my research with you. What I was doing before was that, guys, I was trying to making a graph like this, the one similar with the wispy spoke. But while making this graph, I came to realize that when the fluids was dropping down to the floor, they were getting almost fade away, which is really not the case that is happening inside the realistic dry ice. So just to avoid that thing, what I did was that again I pushed that graph to somewhere on here. I don't want to have the graph to touch the topmost section, because otherwise you may could say that the fluids, when they're going to hit the ground, will going to be extremely heavy, or you may could sense out something different but not the dry ice, which is I don't want in my case. So we like to have the points or the value of the graph ideally in the midway in the vertical sections. Okay, so that's pretty much fine. Okay, now with these settings, what we did, why can't we just play the timeline and we can see what exactly we are getting? Well, I'm sure of the fact that the fluid will really not going to be very supportive for us. And before you play the timeline, I would like you to have your viewport 2.0, and of course with that you should also need to switch on the value of the floating point render target, which is already enabled in my case. That will already we're going to address some few artifacts of the opacity, or you can say the look and feel of the fluids, and this is really gonna increase the final look and feel of the fluids. Okay, so with that said, let me just play the timeline. Okay, so I know that these fluids will not really going to be very effective and essential, because we haven't utilized one of the key attributes of the opacity graph, which is the the I think so. I need to stop the video. I need to recall the one because there's so many options I can't recall. The input bias is exactly the input bias. So just do one thing. I'm gonna stop the video and let me just have the fluids to get a little bit raised inside this bowl, and then I'm gonna show you the advantage using the input bias. All right. So let's just take a break. All right, so I guess the break is over and it was really a short break. So with that, I have just played the frames over 31, and the it's really not looking so good. I mean, it's from nowhere looking like a dry ice, but just don't worry, guys. Just trust me. We're gonna have a very nice simulation of the dry ice. So what important attribute that I was talking about is the input bias. So the moment I'm gonna shift the graph towards the positive uh, section of the coordinate geometry, I guess zero point 0.5 is the ideal start for that, or you could be go for 0.55, but just do not go for too much positive value. Okay, so with this setting, what I found is that if you can see such a nice behavior of the smoke, this is all just because of the viscosity. Okay, and as well as the forward advection also. What exactly the forward advection is doing, guys? The forward advection is not letting the fluid to get stayed or to get static. Okay, and of course it is also maintaining the pressure, because once I was doing this reaction just for my research and the developments, I came to know that if I do not switch on the forward advection, the pressure is getting accumulated in such a way that it was pushing the fluid beyond the limits, and it was never letting the fluid just to come down, because most of the fluids was getting unstable and damaged, and it was get completely dissipated. So I must have to say that the usage of the forward advection along with the substeps is really going to be important. Otherwise you going to end up with some small cranky or the jittery voxels things, which I personally hate a lot. Okay. I also do agree with you that this dry ice is looking completely, you know, flat. Reason why? Because we haven't utilizes the lighting sections, but just you know we would like to move over there. We would like to have first of all the concern to the graph again. I was discussing about this nice and important curve. So what I want to do is that if I would like to dip down this curve, you could see that the softness from the corner side of the fluid will get washed out. So this is, I don't want to do that because I don't want to have the fluids to be really, really hard. I just want to have the fluids to be exactly soft and should also sustain behavior of some smoke. Okay, this is just as a resolution of 60. If I'm gonna take that thing to maybe 120 or let's say 150, then you could imagine that with just the double amount of resolution, it's really gonna have some very interesting details. Okay, so we're gonna have that thing, not a problem. Okay, so let me just have that thing over here, which is quite a good start for the graph and the curve. Now, what would like to go for that? Let's say we like to come for the lighting section so that at least we could have some better look and feel. So just to switch on the self shadow. So by switching this, and I just do one thing. Why should not I hide this object? Yes, exactly. So now you can see that this is really looking very fantastic. And again, this is at the 60 res, okay, 60 resolutions. So what more I want to do with this is that uh, we don't want to have such a hard shadow because this is a very soft and thin smoke. So shadow opacity with 1 is really going to be too much. So 0.65 will going to be okay, and you can see that the moment I'm reducing the value of the shadow opacity, I can see that the light is getting inside of it. You could say that the translucence factor, which is you can say the property of getting the light internally scattered inside the substance or the density, which is here the dry ice. Now again, I like to go for the ambient brightness. Now this will going to play the role of the surroundings. the additional lights of the fluids in the darker regions. So the ambient brightness would like to have, let's say, 0.25, which is, really making my fluids nice, because smoke is really, a sort of a, you can say, um, highly translucent. Like the lighter smoke is always going to be translucent, so it will going to have, let the light travel inside, move inside, and to show the exact physics of translucency. Okay, that's fine. And if you want, you may could also wish to change the ambient color, let's say just for a reaction or for some particular interest. I'd like to go for this light bluish impact, which is just a better form of the white tone. Okay, that's nice. And just to be really very careful, guys, although we do have a dedicated section for the rendering of the fluid, but just in this case we'd like to go for a simple and quick render, and I don't wish to use this real light just for now. Okay, and again, the directionality is really going to be important here, so let me just put that thing to the 0.5 once again, which is also quite good. All right, so I guess with that settings of the opacity graph, the lighting, we are done with this lesson. Now moving ahead to get to know the advanced and the more important attributes of the dry ice in the next lesson.